Patne, Coordinator for Techtalk 2020.
And welcome to the day 2. I wholeheartedly thank you all for the wonderful response for the day 1. Today, day 2, our topic is evolution of automation technology. And to present this topic, we have a very well-known speaker, Mr. Omprakash Barure sir with us. It is my pleasure to introduce Sir front of you. Sir had done his graduation from Government College of Pune and had done his post-graduation from SGGS Nanded. He has almost a decade of experience in teaching various diploma and degree colleges from Mumbai, Pune and Navi Mumbai. His interest in system integration creates his own consultancy as BAGESHREE Private Limited, that is BITC 2104. He is integrating with the PLC, DCS, SCADA and PAC system. He is giving a professional training to many industries such as the IDMI Mumbai, then Vitara Automation Private Limited, JCB Pune and many more like that. Having a past technical experience and the education experience, he is ideally a perfect bridge between the industry and institute. He strongly believes that to increase the productivity, a professional training to the industry is really very essential. He is giving internship to the many engineers for training purpose. It is a pleasure to have you sir with us. Now I request Barure sir to proceed with the section. Thank you.
I'm thankful to Dr. Gowli, who is the head of the Department of Instrumentation Engineering. Thanks to Dipti ma'am, Trupti ma'am, and Divij for arranging all these technical sessions very successfully. And I think here we go. So this is my first slide, as you can see, and the topic is evolution of automation technology. Okay, so as usual, my first question is, am I being heard? Can you hear me? Hello? Hello? Okay. There is a little challenge here because I'm not able to see anybody from here. My audience is not visible to me, and it is as good as monologue for me, right? I can understand that, but it is a big thing that I can address a lot of people from here at a time, and especially during this lockdown time. I would not say after this particular session I would send home, but you are already at home, you are already in relaxed mode. But I will try to finish within time because if I delay, then I will be encroaching into your lunch time. Okay. So as the topic goes, evolution of automation technology. So here let us be very, very clear that we need to look at all these things in a different perspective, right? So when I say evolution, what do you mean by evolution? There is another word which is called as revolution. Evolution means it's a change, it's transformation, and it's in forward direction. It's slow, but when it comes to revolution, it is very fast change. And even when we say in revolution, we think that we are getting a change, but that change is only the modified past, only the past that gets glorified, modified in a certain way, and that comes as a future. So we are not talking about that. Evolution means how the automation technology have evolved. Let us go through some crucial stages. And here I'm assuming that my major audience is students. I'm glad to welcome everyone here, the regular students. I mean, regular means those who are regularly going to colleges, not just who have taken admission, right? Then the freshers, those who have just passed out or about to pass out, or they are in final year now, they are at a transition state. Then practicing engineers out in the industry, and the professors, the faculty from various instrumentation departments, or perhaps all over Maharashtra or even India. It's a very good opportunity for me to interact with you all here. I want this interaction to be very, very clear, understanding, and some meaningful outcome should come from this. So when I have a first slide in front of you, this is BITC 2104. Now, because I'm not able to interact with you directly, but I hope there could be some questions like what is BITC 2104? BITC is, as you can see on the top line, BAGESHREE Instrumentation Trainers and Consultants. 2104 is 21 for developing a new skill. Understand this? It takes minimum 21 days to develop a new skill when it comes to training, and that is why it is 2104. But as you are all a learned instrumentation audience, this might even remind you of some symbol. You remember ISA RP 5.1, you remember DCS symbol, right? This resembles with the DCS symbol. So from that point of view, 2104 could be a tag number. And just below that, I want just to focus on the tagline, that is creativity through understanding fundamentals. Why I'm saying this? Because I can share one incident with you that I met a very prominent faculty from IIT Bombay and we were traveling together. There, of course, we went into a discussion, and as a result, I happened to ask him a question: Sir, are you ever in trouble? Do you ever have any challenges? So he said that what question you are asking? We are always facing some challenges because we are handling new projects always, novel ideas. So we always are surrounded with different challenges. Then my second question was ready. So when you are having some troubles or when you have to face some challenges, what do you do? You understand the question? What do you do? So to my surprise, he said that whenever we are in trouble, we go back to basics. We go back to fundamentals. So I got a very profound message there because all freshers, instrumentation students especially, when they go out in the industry, one thing industry expects of them is creativity, and the real question is how that creativity will come. That creativity is possible only through understanding fundamentals. So I would like to just run through some fundamentals today. I may not be having the very colorful slides. The only color that you will see is on this particular slide only. Rest of the slides are only black and white. And as I understand, all these slides or presentation slides are mainly for me so that I don't skip any information that I want to share with you. So please focus on the interaction, what I am going to talk to you, right? Let us have that as a prominent thing in our conversation today. Next slide is our philosophy. This is what we believe in. Please go through this, take a minute and read it carefully, especially students. Most valuable assets of 20th century company were its production equipments, and the most valuable assets of 21st century institution, whether business or non-business, will be its knowledge workers and their productivity. What do you mean by this? Is there a basic change or what is called as a paradigm shift as we moved from 20th century to 21st century, right? And what is that change? If you just look at this profound sentence, which I got from Eighth Habit of Stephen Covey. In his first book, he talks about his 7 habits of most effective people, not necessarily successful, effective people. And then he came out with the 8th habit. And then in that 8th habit, he says that moving from success to greatness. And in that, he says that this is the paradigm shift that has taken place in the thinking of people when they were in 20th century and when we are now, right now in 21st century. What does this mean? Is that if you ask a 20th century industrialist as to what is your most important asset, what is the most valuable asset, he would obviously say that this infrastructure is very important, right? My asset is this. If I have got a process industry, my asset is a boiler. My asset is all equipments. The land itself is an asset. This is my asset. But if you ask perhaps the same guy now, what is the most important asset now, then he will say that it's all okay, infrastructure is okay, this is all required anyway, but my most important asset now is not the boiler, but my most important asset is the person who is going to operate the boiler. You understand this? The person, and whose productivity is important, that worker who is a knowledge worker, and his productivity is most important to us. Is it a good news for students? Yes. So if you become a worker, not just a worker, if you become a knowledge worker, then you are going to be an asset for the industry. And that's why there is one more step perhaps that is important, that is called as a training. Let's move to the next slide. Is career planning important? Yes. You might have said yes to yourself. I can't hear you. If it is important, then please take a look at this particular data which I got from a government website dealing with the skills development. Parents refuse to give 40 minutes for career planning of their children. Is it true? Then what happens? Most of them suffer and struggle for 40 years in their working lives simply because they were not given 40 minutes to make their own choice. To understand the importance of career planning, so consider the following statistical data. That is 97% of people first finish their journey. What is journey here? Education. And then think about destination. What is destination here? A career. Is it not true? You travel first and then decide and ask somebody, where should I go? That's ridiculous. But this is what most of us are following. And second figure is 94% adults are in either in wrong career or underemployed. That's why we fail to receive the final result. Next, about school students. When they were asked what is their career choice, the most of them said, let us see, देखेंगे क्या होता है, right? That kind of attitude. And most of them are either having unrealistic career ambitions or they follow the crowd, the herd. Unrealistic means what? Definitely about 8% students might have said that yes, I know what I want to do. And they might have said that I want to go to the moon, something like that, which looks unrealistic. And one more data is about our education. Most of us are preferring to go for post graduation. 88% of postgraduates are not able to utilize their investment in education as they fail to understand that fail to understand that degrees lacking employability skills are like a mobile phone without a SIM card. Employability is something important. Employment automatically follows. And in this BITC 2104, whenever we have some training programs and some career planning programs, in that we try to help the burgeoning engineers who are the freshers pass outs from colleges. See, in this our presentation and so-called interaction, I want to really share my thought process with you, right? I don't want to share the static data with you, because the data, when it comes to data, there is a huge data. Information, it is abundantly available at your fingertips, right? So I won't try to give you a lot of data, but I would like to share with you the thought process behind, right? So any thought process begins with an inquiry, and an inquiry begins with a question. And this question came to my mind, that why training is required, right? Has this question crossed your mind sometime? Especially when you were asked to undergo some training, right? You said, why training? Why training? Because you think that when I'm educated, why training is required? Especially you ask the final year students. You ask Mr. Dwij, who is the final year student, why training? He will say that, sir, I am already about to complete my 4-year long course. What training you're talking about? Is it not enough? That's why I say there is something called as an education. We are all educated, are we not? Yes. What education gives us? As I said, these are not academic questions really. I'm sorry if I'm putting in a particular way. These are the questions which have to be really asked to oneself. I'm just a medium you can use through which you can ask these questions to yourself. And questions are very, very important, aren't they? What is more important? Question is important or answer is important? Question, right? So, from this point of view, what is the question? Why training? What is education? What education gives me? Education gives information. Most of you might have said knowledge, but I'm sorry to say what education gives you is information, because that gives you information through around 40 different subjects, and this is full of information only. And that's why when you pass out you feel burdened, because the information becomes the load on you. So what am I saying? Is information bad? Is it not important? Yes, it's important, but the question is it enough? Is information enough? Perhaps you will say no. Then what else is required? You have to begin with information. I'm not saying that information is not required. I'm not saying that education is not required. It is a must, it is a stepping stone. But unless you take the next step, the previous step is of no use. Unless that information gets translated into knowledge, this is what is to be deliberately done. This will not happen on its own. This is not a part of automation, right? Information gets converted into knowledge. You have to do it deliberately. You have to convert it into knowledge. How will you do that? This is where you will use training. And what is training then? It is training just a tool in your hand to transform the information into knowledge. What will you do with this knowledge? Is knowledge the final stage? I'm sorry to say, industry is not satisfied with your knowledge either. You'll be surprised to see this. Then what industry wants? Industry wants your skills. And where do these skills come from? The skills will come from your knowledge, right? As you practice that knowledge over a period of time, again and again and again, what will happen? That will get converted into a skill. And what is a skill? Do you think skill is the habit, right? Skills is nothing but a habit. And skills, here we must understand that skills belong to the body and not to the brain. This is very, very important to understand. Knowledge is of the brain, but the skills is of the body. And every industry wants you to be a body which is skillful, right? So you should work from your habits and not from your whims and your mindset or your mood. I'm not in a mood to work. I don't feel like working. No, no, that should not work. But if you're working through the skills or the habits, you will work anyway. That is what is expected. So what should be the goal of training? Why should you undergo the training? You should undergo training because you want to develop the skills, right? That is the goal. Now, here is another profound question I would like to ask. How do you look at this particular training? How do you look at this training? What do you mean by that? Is training to you a process or an event? Right? Please say, take some time and answer to yourself, although I am not able to hear you, right? And one more thing, whatever I'm sharing here, please don't agree with me, right? Don't agree with me. And another thing is that please don't disagree with me either. Then you must be saying that what is this? You should not agree, you should not disagree. Then what is the option then you have? You please only consider. This is just the thought process being shared with you. So please consider this. Be just open. Don't say yes, don't say no. Because the moment you agree, you are blocking yourself, aren't you? When you say, yes, I agree, this is fantastic information, what does that mean? That means you knew this already. And when you say, I don't agree, what are you saying? By not agreeing, you are again blocking yourself. So you are not moving further anyway. So the third way is just to be considerate, take everything in your basket, and then you can think it over later whether you want to really have it or not. Okay, you can choose it later. So how do you look at this process? Process is an event, or sorry, the training is a event or a process? What is it? Event means what? It's a one time which takes place at a particular time and at a particular place. Event. Process continues. Event has got the beginning and it comes to an end. A process, it begins definitely, but it never ends. It's unending. So what should be training? So when it comes to any conventional training, you may agree with that. Yes, training is an event because it starts on a particular date and it ends on a particular date. Yes, the fact is that training is an event, but I challenge you to convert this into a process for you. Once you finish one kind of training, please think that how do I continue this into another kind of training so that this becomes a complete stream and it becomes a continuous process. Okay, how do I go to next slide? Yes, yeah, my slides is full of questions, right? Please don't get angry with me because these questions are moving questions. They will trigger you off and think in a different direction. Now this is a $1 trillion question right now. Yeah, not million, $1 trillion question. What is instrumentation? Right? So I still remember when I got my first answer to this question through a book. There is a book called Instrumentation by Kirk and Rimbaud, right, which I got in a library. And I went through this, and on the very first page, there he had given it the definition. And this definition reads like this: Instrumentation is the technology of using instruments to measure and control physical and chemical properties of matter. And as the years and decades went by, this definition really became true for me, right? Unfortunately, in our education process, we begin our journey with the definitions and laws and everything, right? Which it should not begin with that, because you have no experience and you are learning a definition, and that definition is just the set of words. That's it. Nothing. It means nothing to you. But if you just ponder over, if you think about it, then you will definitely slowly, gradually will go beyond the word, right? So what does this mean? I have highlighted the word using, using this technology, right? So what are we? What business we are in? We are in the business of using technologies. Which technology? Not a specific technology, any technology. We began with mechanical, then went to electrical, then to electronics, then telecommunication, then the computer and IT, then IIoT, then the wireless, wired, everything, a networking, a technology. It's just a technology for me. I must become good at using the technology. Please remember this. This is a fine line difference. I don't have to be the domain expert of the technology, but as an instrumentation engineer, I must be very good at using these technologies for my goal, right? And in this definition itself, this has got the scope also. It deals with the physical properties of matter. When it comes to physical properties of matter, means what? Industrial instrumentation. What do you mean by industrial instrumentation? What do you mean by physical properties? You please go on digging deep with a particular question. Don't stop, and don't stop until you get your own answer. For some people, physical properties could be their final answer, but for beginners, they will say that what do you mean by physical properties? Then the next answer could be, oh, physical properties uh, of matter like temperature, pressure, level, flow. Then they say, yeah, I understood now. Temperature, pressure, level, flow. They understand temperature, pressure, level, flow, but they don't understand physical properties, right? And the technology dealing with all this is referred to as industrial instrumentation. And there is again equally important field called analytical instrumentation, which basically deals with chemical properties, which is analytical instrumentation, which is a separate subject in itself for instrumentation people, right? So we are dealing with this, and we are using all these technologies to meet our end. There are some basic confusions, right? These confusions I came across when I was there in academics, and the same confusions were percolated through the industry also, right? So what are these confusions? Some basic confusions are, the first statement is, you might have heard about J. Krishnamurti. He used to always say that word is not the thing. This is equally true in spiritual world as well as scientific world. Word is not the thing. What do you mean by this? The word is not the thing. For example, the word RTD is not RTD. Correct? The word RTD. Then you will say, yes. Do you know RTD? Somebody will say, yes, I know RTD. What is RTD? Resistance temperature detector. Still you do not know. What you know is the long form. So the word is just the representation of the thing. And why we begin with the word? Because that is how we have to begin, because this is the communication. It's a learning and teaching. That's why we have to begin academic world with the word. But please don't rest until you reach the thing. The word is not the thing, but the one who says that word is the thing, he or she becomes an examinee. Yeah, the word is not the thing, but you think that word is thing because you think that you know RTD. Why do you think you know RTD? Because you know the long form of RTD. Some better student or maybe your topper, he will say that I can write 2 pages on RTD, but still you don't know RTD, right? Unless you have worked with an RTD, unless you have seen how that physically works, unless you have seen its applications, you will not know RTD. So please don't rest. Don't think that I have understood, because someone said that he who says he knows nothing. Right? He knows nothing, and that's true, because what he knows is the past. It's gone, and our science and technology is always new, right? So never say that you know. I'm knowing. That knowing is going on. This is a dynamic thing. This is the verb knowing. That is true. So word is not the thing. So let us make an attempt through this particular small presentation perhaps. Especially I would like to urge the students to go beyond the words. Go beyond the words, go beyond the theorems, go beyond your postulates, right? Go beyond your statements, definitions, right? For example, if I can share with you, when I talk to students, right? And if I give them some small example to work out and prove that this is so and so, they will definitely begin with that. If it is an electrical problem, then they will say that according to Ohm's law, right, this is this. The guy is very smart. In the beginning only he says that according to Ohm's law he does blah 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 blah, and finally he says that this is wrong. Then who is wrong? Then he will immediately say that Ohm is wrong because I said that this is all according to Ohm. But my question is, when will you say this is according to my law? When Ohm knows, that is his law. But the moment you know, that is your law. When will that moment come? When will you take that complete responsibility? That this is my responsibility. I will be responsible for the results. This is what I call going beyond the words. You read the books, right? When I'm talking to students, especially, I would like to say that what kind of books they are reading these days. I know I'm in touch with them, right? They say something called a Tech Max and something like that. That really hurts me. What Tech Max, right? Because they say that no, this is a very good book because that covers the complete syllabus. Then my profound question for them is that which book will you read, man? Which book will you read? The book which is written according to syllabus, which will conform to your syllabus, or will you read the book which is referred for making a syllabus, the textbook? Which book will you read? And when will you read those basic books? Right? Please pay attention to what you are doing. I'm not here to console you. I'm not here to tell you that world is beautiful outside. Don't worry, you just pass your exams and everything is a rosy bed. I'm not here to tell you that. Please pay attention to what are you doing and be answerable to yourself. So word is not the thing. These are just only the words. Unless you go beyond the word and see the thing and experience the thing, the word will not have any value. Right? Second confusion is, as I showed you in the slide, instrument and equipment. You heard it right? Instrument and equipment. What is the difference between these two? What do you mean by instrument and what do you mean by equipment? Are they same? Are they synonyms? Yes, for some that could be synonym. That could be synonym means what? The meaning is same or similar. No, never same. Similar. If two words are having same meaning, why it should be there in the dictionary? Is our objective of making a dictionary is to make it big? That's why we have got so many words? No. So please pay attention to this. What is instrument and what is an equipment? We are passing through this lockdown period, and one thing, have you ever seen or noticed there is how the things are shifting to instrumentation and automation? How this will become very prominent even during this challenging time? Haven't you noticed the advertisements of dairy products? I could notice those, some Gokur or some other dairies. They would always advertise their products with some smart the model behind or beside. But now how they are advertising, you have understood? They are showing their process, how it is without the human touch. They are showing how they are manufacturing these products, dairy products, and how good they are, how quality they are. They are trying to show you. And then they say that, yes, please buy our products because they are quality. But they are showing you the proof online, right? What you saw when the this COVID-19 and this pandemic came in, what is the first thing that you observed? Is the gun. Which gun? It's not a shotgun. It is a, right, this gun. It's an IR thermometer. This is an instrument. So what is an instrument and what is an equipment? We must make it very clear. If I give an example, I won't go into much details because the time is crucial, and I won't be able to cross the time like Lalit had his liberty yesterday because it was the evening time. This is afternoon time, and the very next event is your lunch, most favorite. So instrument is IR thermometer is an instrument, and sanitization chamber is an equipment. You understood? Your holding tank, a reservoir is an equipment, and a level gauge fitted on that is an instrument. You must understand this difference. You see, this will make a huge difference in your understanding of industry when you go outside, right? Another thing which I want to mention here is, as I'm talking about students now, right? Let me just finish off with this. Maths is one of the important subjects. Yes, you will say it's, it's, important. How many marks you got? 40. How many marks you got in 12th? 99. What made the difference? How come you got just 40 in engineering and 99 in 12th? You are not wrong. I understand your answer. I understand your psychology. I understand the bad time that you go through because you are all doing maths and maths so mechanically that you are never told the significance. Let me tell you what subject you had. You had maths or it was applied maths. I'm sure it was applied maths or engineering maths. Nobody does that application or engineering with maths. It does just the maths and just 40 minutes over. It is something hurdle that you want to cross over. This is not an attitude. Instead, what should be an attitude then? Attitude should be to look at maths as a tool for understanding engineering and technology. What's our problem? Is our problem a mathematical problem? Right? I think I can relate with the student community. Is our problem a mathematical problem? No. But we began our journey with mathematical problem. We solved so many mathematical problems. What did you get? Solutions. Solutions to what? The problem. We never understood the problem. How will you understand the solution? What is our problem? Our problem is engineering problem. Right? What's our problem? What's our problem? Our problem is engineering problem. Like what? I have got a tank, a dynamic tank. The material is coming in, material is going out. Maybe a reactor, a bioreactor these days, right? And in that, I have to control the level. That is my challenge. That is my problem. So how do you look at that, right? So in one of the conversations with some faculties, I just observed that the candidate was asked to draw a tank on the paper, draw a tank, right? Okay, so first candidate drew a tank, an engineering graduate. He drew a tank, a big tank with thick walls, double line, a pipe coming in, pipe going out, the water coming in. He showed some animation sort of thing also. And he said that this is the tank in which water is coming in and water is going out. Then the examiner said, are you an engineer or MF Hussain? What you have drawn? You have made a painting of a tank. Can't you make a line diagram? Right? A line diagram. Yes. Another candidate drew a line diagram, simply a single line diagram, single line water coming in, water going out, and he showed the level also. That's it. Simple. Engineering drawing, which you have learned in first year. But even this was not acceptable to the examiner. Right? This examiner was not an examiner, he was an interviewer. He was there to select you for the industry. He rejected even that solution. Then which was accepted? This was accepted. That when one's candidate wrote dv by dt is equal to a into dh by dt, right? This is what? This is a tank. This looks like a tank, right? Can you see the equation? Then you will say that this is not a tank, this is maths. What maths? This is a differential equation. No, no, this is not a differential equation. This is a tank. Do you understand this? What is the tank? What is V? Volume. What is T? Time. H? Height. The level. A? Area of cross section of the tank. So dV by dt is equal to A into dH by dt. Isn't it a tank? Yes, it's a tank. It's not a maths. This is only the representation that we are using maths as a tool to represent our engineering problem. Now you do something with this. This is what is called as a mathematical model. This is a dynamic model because we are dealing with rate of change of volume, rate of change of height. If it is simply V is equal to A into H, this is the static model. dV by dt is equal to A into dH by dt is a dynamic model. Am I right in this? Yes. So how do you look at maths? I'm not at all interested in derivative, integration and all that nonsense. But yes, am I not interested in tank? Yes. How can I solve my tank problems? Can I just experiment with the tank under the hot sun, or can I sit in an AC lab or AC chamber and work out on this maths and come to some conclusions that how do I apply my instrumentation and control this particular tank problem? This makes a huge difference. No, who talks about this whether you get more marks or less marks? Even if you get 99 marks, this cannot be justified, because when it comes to your examination system, we have beautiful examination system. How beautiful it is! You have got a written exam and you have got an oral exam. What is the difference between written exam and oral exam? Written exam is what? You are answering the questions. In written exam, you have to answer the question. You will say, the what big deal he is talking about? Of course, we have to answer the question. And in oral exam, there also we have to answer the question. No. In theory exam, you answer the question. And in oral exam, you answer the questioner. You don't have to answer the question, because the person who is asking that question, that person is also important, and answer to that particular question is also important. And if you satisfy both, then only you will pass in the oral exam. So this is quite possible that one might get 100 out of 100 in theory exam and he can fail in oral exam. This is very much possible. There is nothing illogical about it, right? So I just wanted to do this. I hope you are getting the message, right? What message you have to get? How do I take interest in my subjects, right? How do I master those subjects? Don't worry about industry. Really don't worry about industry, which industry you are going to join and all that. I will talk about a little bit about that also, but don't worry about that, right? Another confusion word is mechanization and automation. Mechanization and automation, right? So this I will talk a little bit on in the next slide. What is automation? Another question. I hope you are not bored with the questions, right? I might delay a little bit, right? Because I just want to go through these slides first, and then I will definitely ask some questions, uh, and I will answer some questions. What is automation, right? I will go to next slide and give you the answer, because I can't really interact with you, because if you were really in front of me, I would have really talked about your responses. Can this definition be like this? Any mechanism that takes place on its own in a desired manner without human intervention. Yeah? Any mechanism. Mechanism is mechanism. Do you think mechanism has to be mechanical? Not necessary. Two gears, you know, together, right? One moves in clockwise direction and another moves in anti-clockwise direction, right? Isn't it a mechanism? Yes, it's a mechanism. Is it mechanical? Yes. But if I say that there is a wire and in which current is flowing, isn't that a mechanism? That's also a mechanism. This is seen and that is unseen. Electrons revolve around the nucleus. Isn't that a mechanism? Yes, it's a mechanism. So any mechanism that takes place on its own in a desired manner, most important thing, and without human intervention. I'm not using the word human efforts, human intervention, right? Nowadays, in this particular lockdown period, what's more important? No human touch. What does this mean? This is a new definition of automation, right? What do you want? We want automation everywhere, right? When I come from the market, what I expect, the door should be automatically opened. What am I expecting? Automation. So do you see there is a huge scope for automation, right? Ask these questions and get answers. So desired manner means it is your human desire. Whatever is happening exactly as per your desire. Please try to understand this. This is nothing happening against your desire. And that is where I want to answer some people who ask, is automation against man? No. Is automation against employment? No. Is automation there to take away somebody else's job? No. If you want, it will. If you don't want, it won't. Please give a thought to it. This is very, very important, because those who think that automation is against employment, they won't be able to love automation. Let me tell you. I'm not in a position to go in details really. Otherwise, I would have used some examples and made it very clear, especially for students. And human intervention is important, not human efforts. When we talk about efforts, we are talking about machines. Please understand this at this particular juncture. We are talking about machines. Mopping, for example, my mopping the floor, which is actually, which I am doing nowadays, right? How difficult it is, I understand. But instead, if I have a mopping machine and if I just sit on that, which is battery operated, which just moves around and all mopping is done little bit conveniently, would you call that as automation? Many people will call it automation. No, that is not an automation. That is mechanization, machines. Automation comes when there is no human involvement at all, no intervention at all. I just enter my room and I just find it very, very neat and clean. That is what is automation, right? And why I'm doing this? Because I want this. I want this. Like if you just pay attention to some terminology in industry earlier, not very long back, about one or two decades ago, HR department, which is now, was called as a manpower department. Manpower department. Why manpower? Because man, that muscle power was required, and men were required. Why men were required? Because they had muscles. Natural biological difference between man and woman, right? But now whatever you used to do with your muscles, it is being done with the machines, and your muscle is obsolete. It's gone now. And that is why men and women are at par, not because of some political decision somewhere, it is because of the technology. Now, the muscle that we talk about is this neuro muscle, which is equal in male and female. And that is how the gender equality has come. We have one very prominent word in automation that is called an HMI, human machine interface. What is the old version? Man machine interface. Man is no longer a man. What about a woman? It is neither man nor woman. It is human. Neuter gender, right? There is a very, very strong significance to automation. Please take it very, very seriously. Then next question comes. Once you have understood what is automation, right? A so-called definition of an automation, right? Then why automation obviously comes to your mind. Not an academic question. This is a fundamental question that comes from within. All right, this is your question. This is not my question. These are the questions which I have gathered from the people in industry and in academics. They have asked me many, many times. These are the questions I have put in my slides. Why automation? Would you agree with me? Profit, quality, cost. Please check whether you agree with this or not. Safety, and the latest one, which I really discovered, I would not include this in my presentation. But when we did a pan-India training for ITC, North, South, East, West. So when I was there in Mysuru, there they said that these are not only 4 objectives of automation or why automation. There is one more that is called delivery. They were manufacturing chocolates. They said that it is our responsibility to make sure that the chocolate is in the same good condition until it enters the mouth of my consumer. So in that, the scope of automation increases, it goes beyond the factory, and even the quality delivery is also important. So PQCS D, a pentagon, this is the objective of automation. This is the answer to why automation. But these are professional terms, right? Why automation? But in our very, very ordinary language, if you ask why automation, then you will say, how do you really understand automation? Would you understand automation? Because are we not used to understanding certain terms through their opposites? Right? When it comes to definition, how do we define pressure? What is pressure? So how do we begin? Pressure is nothing but. We always begin with nothing. It is nothing but what it is. So what is the opposite of automation? Manual. What is not manual is automation. Am I right? Right. So what could be the benefits of automation? These are the 5 benefits. But some students especially might think, even professionals might think, that you have not included many terms. For example, what? You have not included the what is productivity. Oh, productivity is not the final goal. Why do you want productivity? Because you want profit. So productivity is hiding behind the profit. You would say that no, you have not included the accuracy. Yes, accuracy is hiding behind the quality, right? The consistency, it's hiding behind the quality. So these are the most generic terms. Unfortunately, what happens, we don't understand generic terms. We understand particular terms, but our journey of education and learning, everything takes place through generic terms which we don't understand, and sometimes we just get a feeling that we have understood, and that feeling will really ruin you, saying that you have understood. What you understand is not you understand, you think you have understood. And if I ask you, tell me in one word, what will be the benefit of automation or why automation? Just one word. Don't tell me 5 words. What will be that? Yes. What will be that? Optimization. I'm not getting a feedback here because I'm not getting those online chats also. Right? What is one word? One word today, as a new instrumentation student, you must go and tell industry people that what is the objective of automation, why you want to go for automation. You must say that I want to go for automation because I want to optimize the plant. Optimization is the goal, right? Optimization of what? These 5 parameters which are there with a particular system connected to each other. If you try to improve one, that will affect another. So what do you want ultimately? What do you want? Optimization. Optimization is the goal. The next question, obviously, is it okay? What to automate? What to automate? What will be the answer to this? Automation of what? What is there in your home? What do you understand better? Home or industry? Many people say home because they have spent more time at home than in the industry. Machine automation. What is one thing that is automatic at home? Washing machine. It is a machine that is to be automated. Wow, what to automate? Please pay attention to the verb automate. Many people wrongly say automize. Automation is altogether different. It's a mechanical process, converting something into atoms. A sprinkler is an atomizer. Automation is different. Automation is different. Automize is different. Automate is different. Machine, because when it comes to crisp communication, we have to use very crisp terminology. Machine, machine automation. Next what? Factory. What is the difference? Many machines together makes a factory? No. Machine automation, a machine, a totally automatic machine. I can show you 2 pictures. A machine, a lathe machine with a smart operator, right? Who is called as a turner and a machine. That is a good picture. But if I show you only the picture of a machine and there is no man and that is still working, that is automation. And if you have such CNC machines, for example, 100 machines in your single location, would you call that as a factory? No, perhaps. Unless you also automate something else apart from machines, if you also automate the coordination between machines, and that whole thing together will be referred to as a factory automation. What else can be automated? Manufacturing process. Lalit spoke fantastically on this yesterday. In fact, his lecture is a prerequisite for this lecture. Right? He has spoken. Yesterday was a pharma day. Manufacturing processes and process automation is one of the subjects for instrumentation people. Very prominent, very important. And next could be most four important I will be just mentioning here: infrastructure, which is in short called as a building automation nowadays. But infrastructure automation has to go very long way. This is just infantine time for infrastructure automation, home automation, building automation. Everything is going to come. I will just give you a picture about this, because when we talk about automation of a particular room here, means what? Automating, measuring, controlling some parameters, right? So that it's an AC and everything, atmosphere is also controlled, humidity is controlled. That is what I call automation of a room, a clean room concept in a pharma, for example. But what if can I extend this to a particular floor or a building? Yes. If the whole building can be automated with all its infrastructure, right, that is called as a building automation. Then everything comes, all these utilities and blah blah, electricity, then entry automation, everything comes. That will be an infrastructure automation. What about the colony? Yes, whole colony can be automated. What about the complete city? There is something called as a smart city. What is this? Is it not an extension of automation? Yes, it's an extension of automation, infrastructure automation. What about the city that is on the land? Yes. What about the city that is floating on the waters? Naval automation. What about the city floating in the air? Aerospace. What about something floating in space? Space automation, right? So automation is boundless. You have to just open up the floodgates and things will take place on its own, right? These are the types of automation. The academic question could be, what are the types of automation? I would not prefer that question. What to automate? A fundamental question. Are all manufacturing processes same? Answer is no. Then what is the next question? What are its types? First process type is continuous. Second process type is obviously discontinuous. There are only two types, right? Continuous and discontinuous. Discontinuous may have two types, which is batch and a discrete. Like what Lalit spoke yesterday, he talked about a process automation and discrete automation separately. I would like to look at it differently, like these are the processes which has got a batch process and discrete process, right, and a continuous process. Every process model has got a raw material and finished product, and there is a time. When raw material is infinite, finished product is infinite, and the time required is infinite, continuous. When the raw material is finite, limited, and the finished product is also finite, time is also finite, that could be batch. But the beauty of batch, or the specialty of the batch, is that output, the final product, is a homogeneous mass. This is the distinction between discrete and batch. And when it comes to discrete, if the particular product has got a specific geometry and if it is countable, then that comes in discrete, right? Examples, because what we understand better, especially students, are examples. Sugar factory, a continuous, right? Tea making at home, because I always look upon this batch industry as an extension of a kitchen. What you do at a very small scale in a kitchen, that has to be done at an upscaled version, large scale in the industry. Making a tea is what? Is it continuous or batch? Think about it. It cannot be. But the basic difference between continuous and batch is that continuous is what? Why is it called continuous? Because there is a continuity between feeding of raw material and obtaining finished product. There is literally a continuity, and the moment there is a break, that is a batch. And batch itself means limited, and this is the basic difference. And discrete, maybe automotive industry, a car manufacturing industry, right? Any assembling kind of thing or a bagging, packaging kind of thing, this is all discrete. So discrete, batch and continuous. How to automate? Next question. I have not finished with the questions. New questions will come out. How to automate? Or more appropriate question will be what exactly we do in automation. This was the question asked by a student in one of my sessions in foundation training. That is when the people join our company and we have to take them undergo some training. That time he asked or she asked a fresher, what exactly we do in automation, right? Because how is not a good question, but the last question. When you are interested or when you want to participate, then only you ask this particular question, right? What exactly you do? We measure what parameters? Which parameters? Process parameters. Like what? Temperature, pressure, level, flow, physical, pH, conductivity, density, turbidity, blah blah blah. Analytical parameters. We do measurement. What else we do? Exactly we do. We are asking exactly. Control. What do we control? The same thing which I just mentioned, process parameters. Select parameters can be controlled. What else? We need to compute. We need to do some maths. Automation systems will have to do some maths. Let us see in details, little bit details, not very much details. We don't have time. It's already 1:10. Maybe I will take another 10 minutes. That's it. And after that, we will break for question and answer session. What do you mean by measurement? Please go through this. As I said in the beginning, I want to share with you thought process. When it comes to measurement, I know, everybody has done measurement. Most of you have spent 30, 40 years in this instrumentation industry. But this is really literally a fresh question which you can ask yourself, what is measurement? And if you are very honest with you, the first question, what I want to measure? Measure means what? What do I want? What I want first is end device display. Measurement of temperature, right? How do I know whether one is corona positive or negative? Measure the temperature, right? What do you want? I want a measuring device. Means what? What do you want? I want display, man. I want display on which it should be displayed either in degrees Fahrenheit or centigrade, Celsius. Doctors understand degrees Fahrenheit better, so it's in Fahrenheit, right? So end device or a display, which is a generic term. What do you want now? Then real question is, for example, if you take a particular example of a temperature, the temperature is to be displayed on a 7-segment display, for example. What do you need? You have a 7-segment display first. Please understand this. What do you need now? Oh, how do I bring that particular temperature onto this display? Then I understand, oh, I need to go back to basics. And what is temperature then? The temperature is energy. And energy has got the forms. Energy can neither be created nor be destroyed. What we can do with the energy? We can transform. Now, can we change that form of energy into something which is compatible with the display? Display works on electrical stuff. So can that be converted into a display, the parameter which is compatible with display? That is where we think about a sensor or a transducer. Not much distinction between sensor and transducer. Once you go out of the academic world, this is same. Sensor is the primary transducer and transducer is the transducer. That's it, nothing else. Okay, so sensor or what does it do? Transducer converts one form of energy into another. What is one form of energy? Temperature. Converts into what? Electrical parameter. What can be that device? An RTD, right? Now once we have an RTD and once you have a 7-segment display, please pay attention to this. Is it enough? I'm asking fundamental question. Is it enough? Will you be able to tell me how much is the temperature? You say, what nonsense you are talking, sir? This is giving me the resistance, and what I have is a 7-segment display. It needs some voltage as an input. Then how do I convert this resistance into voltage? That is where the third portion comes. This is called as a signal conditioner. This may be a Wheatstone bridge. This may be an amplifier. This may be an ADC. Blah blah blah. Right? This is electronics. We need to understand this. We don't have to design this, huh? Please, we need to just keep our borders safe. Don't cross the borders. Let others also live, right? Electronics and telecommunication people should also survive or not. They happen to be your one-time friends and classmates, right? Signal conditioner. So in this particular sequence, now what I'm trying to tell you here, especially students, is that I need to ask three prominent questions. What is the display, what is the transducer, and what is the signal conditioning? If you get a satisfactory answer to these three questions, you have understood measurement. That's it. How about control? What fundamental questions will you ask about control, right? Control consists of what? It consists of measuring and transmitting unit. Measuring unit means the last slide. All these three blocks. You need all these three blocks, right? And in addition, you might need something which will convert into a signal that can be transmitted to a long distance. And that standard transmission signal is 4 to 20 milliamperes current, a DC current. So we need additional signal conditioning, nothing else. What else you need? A controlling unit, a controller. Then what? A final control element. If you answer in a particular sequence, I understand that you have understood. But if you say final control element is the first one, first part of the loop, first instrument of the loop, then controlling unit, and then the transmitting unit, I understand all three have been covered, but not in a particular sequence. That's why understanding is missing. You have to go the way the signal moves. You understand this? Control. And what do you mean by compute? This is a little bit perhaps new to some students. Computation is what? We need some calculations. We need some maths, man. Where? For scaling. Scaling means what? What I get final signal as a voltage. Now that voltage has to be converted into degree Celsius or degree Fahrenheit. This is called as a scaling. How much voltage should correspond to how much temperature? That is called as scaling or calibration. Right? Here we need some calculations. Now who will do those calculations? The automation system will do that. What is another use, or where do we use computation? Here is another word which I want you to understand: actionable data. Once upon a time, we wanted data somehow. Give me data. We had no sensors. We developed the sensors. We gave them a lot of data. Now the plant generates huge data. Now what is your problem now? The operator's problem is that there is a lot of data. Please get me rid of this huge data. I don't want huge data. Why? Because he's confused now. What do you mean by actionable data? Converting this whole huge data that is coming from data acquisition systems, SCADA, PLC, DCS, blah, 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 that has to be selectively filtered and displayed for the sake of operator. This is called as actionable data. The word is beautiful. Actionable means the data on the basis of which you should be able to take some action in the plant. This is actionable data. This is the role and responsibility of an automation system now. And another thing is analog and discrete and digital and representation and all that. Haven't you all seen SCADA screens? In a SCADA screen, there is a tank, for example, and in that level is moving. As the level moves dynamically, actually in the field, that is actually shown on your computers also, right? So how would you like that to be displayed? Yes, I can very much display that, say that right now the level is say 1.2 meters. Is it not an indication? But operator will say that I'm not satisfied with that. Please show that, display that in terms of a bar graph, so that I will understand. Means what? I will understand actually. Because if I say level is 1.2 meters, next question is obvious. So what is the height of the tank? Because you want to understand whether it is half, a quarter, or 3/4, or overflowing. This is what you want to know first. Or an excellent example I can share with you is that what kind of watches you are using. Are they analog watches or digital watches? They are all digital, but the display is only analog. Why are you using the analog display? For example, now what is the time? Right? Quarter past 1. When can I say quarter past 1? Only when I look at analog display. And if I look at a the digital display, I will say 1:15. If the time is 1:59, the meaning is that what I assume is that it is still 1 o'clock, but the very next moment it is going to be 2 o'clock. This is the beauty of analog, and that is why we prefer analog. The operators prefer analog. In a nutshell, what could be the automation tools? You have to look at certain things as automation tools. Can a simple electromagnetic relay act as an automation tool? Yes. Relay logic control, what is that? It's an automation tool. Embedded systems, yes, it can be an automation tool, right? In IIoT, we are using embedded systems now. Like yesterday, the Lalit said, the sensors and the embedded systems, the softwares, right? Then PLC, which is a generic term, is programmable controller. That can be an automation tool. SCADA can be an automation tool. And this is the evolution. This is the way the technology has evolved. Where is the evolution takes place? Not in the task, the way we execute the task. There the evolution has taken place. DDC, which is a centralized control system. DCS, a distributed control system. Both are tools. Tools are not bad. You have to find out what kind of application you have. I cannot say that DDC is the best. No, this is nonsense. DDC is best for a given application. Just like that, your robo is a tool. Robo is an actuator. AI, artificial intellect. It's not a spelling mistake. I think this should be corrected as artificial intellect and not artificial intelligence. Intellect is memory based. The more the memory, the better the decisions. Intelligence is something else. Intellect is always limited. Used or applied intelligence is intellect, right? And intelligence is always natural, artificial intellect. So artificial intelligence is so-called artificial intelligence. It is giving very fantastic results in process automation, right? Even in my mobile, if I just, my friend name is for example Madhukar Kulkarni, even if I just type yum, it displays Madhukar Kulkarni simply because he is my dear friend and always I have been calling him. How does the instrument knows that? It's artificial intelligence, right? Drone. Drone is again a tool in your hands. New technology, the new motors, BLDC motors, everything that you have to study. Like Lalit said yesterday, you have to be really, what you can say, poly skilled person, right? You have to be. I don't have to be an expert, but I must at least come to know that what that particular another field has, so that I can serve them better. IIoT, right? A cyber physical system. This is also a new automation tool. This is the evolution. Logic control, I will just run through this. Relay logic controller, what are its limitations? Why I'm saying this, these are the limitations, because why I'm interested in limitations, simply because I will understand the advantages of the new system. Why I'm concentrating on limitation, I'm not a negative person. I'm concentrating on negative demerits or negative points of the existing system, simply to highlight the positive things of a new system. This is what I don't like about relay logic, right? Then what do you mean? I want to go for new system. What do you mean by new system? Don't name that new system. But the new system will have exactly something which is opposite of this. That new system will have a small size. New system is going to be lighter and very flexible. New system will have no maintenance, right? Just make opposite of this. This is what new system is going to give you. What is that new system? PLC. How do you look at PLC? What is your perspective? It's a relay replacer, right? Don't we define new things in terms of old? Please pay attention. This is very interesting. A new cannot be explained with new terminology. A new has to be always explained with the old terminology. Something which has replaced relay is called as PLC. This is very fundamental definition. And that's why I always say, even if you are an engineering student, you cannot ignore the history in engineering. History is very, very important. It can be a tool for automation. Look at it. This is a new definition. This is not a text definition. This is not coming from a textbook. This is coming from your thought, how you look at it. Programmable controller, a new definition. A logic solver. Oh my God, what does it do? It basically solves the logic. A smart and intelligent control system. Hardware and software control system, both. And they are not standalone instruments. They are the control systems in themselves. What should a PLC contain? Here I just want to tell you, convey one message, that I did not say that what PLC contains. Means you already know what should a PLC contain. Please think about this. What it should have. Should it not have IO modules? Yes, IO modules are nothing but electronics. I don't have to go into deep. I work the PCBs and the modules and above. That doesn't mean that I don't understand those PCBs, but I am not supposed to do that, right? I'll be more effective if I maintain those borders. Do you think without power supply no module works? Because module is a signal conditioning. Do you think for decision making, for logic solving, which is mathematics, you need a central processing unit like microprocessor? And do you think this is all memory based? That's why you'll have to store it something, because the very word is programmable. Where would you store the program? That is where memory comes, right? And how do I interact with that? What will be man machine interface? That is something called as a PC like device, which is a programming device. So whenever somebody tells me that what kind of PLC will you teach me, I say that I will not teach any PLC. I will just teach PLC, right? Not Allen Bradley PLC or Siemens PLC or this PLC. PLC is PLC. You should know PLC. Another thing is that I ask them, do you want to know PLC or you want to know about PLC? They say that I want to know about PLC. Then go away from here and go to Google lady and find that information. She will give you much more information that I can give. But if you want to know PLC and not about PLC, then I can perhaps help you. What are PLC specifications? Be clear on those specifications, because we are technical people. Without specifications, we cannot understand any device. Talk about orifice plate. What are the specifications of orifice plate? You know everything about orifice plate, but you don't know about specifications about orifice plate. Means what? You fail to understand a particular device. You know, what should you know about an orifice plate? Don't you think you should know the MOC of orifice plate? Don't you think you should know the thickness of an orifice plate? Don't you think you should know the bore dia and this position of an orifice plate? Yes. So this is all converted into a standard language. You ask for a beta ratio, you will come to know about the dimensions of the bore. You talk about the shape of the bore, you will come to know about the type of the orifice plate, right? Orifice plate is a very, very important device. I'm not saying that this will go, because this is something which is working with mechanical systems. Once orifice plate converts its signal, a DP, into something else, then our systems work. Then it can be up to DCS, PLC, whatever it is. Quickly, what could be the specifications? The very first specification of anything should be a make and model. Type, IO count, IO types, speed, memory, communication. I'm just showing an example. My purpose is not to teach you PLC, but how do you understand a particular device? Even if it is an IIoT device, what should be its specifications? If you ask these 10 fundamental questions, you will understand everything about that particular device. What is DCS? This is a picture which I got from the book. Is it from Anderson? I don't know. But this is from a textbook from ISA, right? This gives you a very clear-cut picture about DCS. Nobody talks about this. This is a hierarchical distribution, process instruments, then IO modules, local IOs, controller modules. This is how you need to understand DCS. What do you mean by control philosophy? Here I want to show you something like, share something, the thought process. People say, what is next? What is new in automation? Oh, what do you mean by new? Why do you need new? For example, here in this particular pyramid, at the bottom most what I have written is temperature. What is your example? Actual example is this on your right hand side, and this is a generic term on your left hand side. You please find out whether you understand this or this. This you may not understand. Left hand side you may not understand. You will understand right hand side. I want to measure temperature in a factory, in a process industry. What is that? Then the parameter under measurement is temperature. That has to be converted into resistance. That has to be further converted into degrees Celsius, further converted into fewer, whether you have to draw a conclusion, whether, if it is an example, I'm sorry, if it is an example of COVID-19, whether you have got a temperature or not, it's a body temperature. then you will have to conclude whether it is a fever or not, right? And after that you will have to prescription. So same thing happens. Now at what level we have the automation now? Is it just a parameter measurement and converting into a signal, or have you converted into a calibration and given some information and you will come to know how much is the parameter, or you can convert that parameter into some knowledge also, which is generally done by process people in industries. And wisdom is taking a decision also, prescription also, going up to that. Now up to what extent it is taken over by automation system and up to what extent it is taken over by the humans, this is what decides the level of automation. Like yesterday the one term came, ISA 95, right? MES ERP integration, it's a ground floor to top floor, shop floor to top floor integration, right? If that whole thing is taking place absolutely through automation system, then that is a very high level of automation that we are having. Automation industry types, this is very important slide, please pay attention to this. Yes, I am exceeding time. Automation types, so but let me tell you, when it comes to automation types, right, it is solely based on one word, that is instrument. Instrument is required. The one which manufactures the instrument, one which manufactures and one which uses. Now who comes first? The user. The instrument is used by somebody, that is called as an end user. This is the first component of an automation industry. Then when there is a user, then there is a manufacturer, instrument manufacturer, he is called as a vendor, right? These two are enough, a third one is required. Instrument is manufactured and instrument is used now. Do you need anything else? Yes. The third one, a consultant. Hello? Hello? Consultants are the third factor, and a control systems integrators, a company like ours, those who are into the integration of the control systems business. This is the fourth one. What is the fifth one? Left one, the most important and the biggest one, is original equipment manufacturer, OEM, and these four will make an automation industry run. Manufacturing industry trends. Yesterday a lot has been talked about this particular thing, but nobody talked about what is industry 1.0. Industry spelling is German. Industry 1.0 is mechanical. Example I am taking here is picking the water from the well. Is it a task? Even today it's important. Yes. What you need is a pump. If you are getting the water out of the well with the pump, then it is mechanical that comes into being, and this mechanical happens to be the industry 1.0. Industry 2.0 is a pump, not just a pump. Can there be a pump without motor? Yes, hand pump can be a pump, but we got bored with that and we said that that pump must be associated with motor now, and task is same, you please remember, picking up the water. Electrical. Industry 3.0, pump will be there, motor will be there, and in addition to that there will be drives now. How to run the motor, a smooth start, smooth stop, there is a lot of self diagnostics and all that. And how did that came into being? Through the advent of electronics and computer technology. That was industry 3.0, and now we are talking about industry 4.0. What is that? We already have computers in place, we already have the networking, and what is required is that we must have the network of physical systems, that is called as an IIoT, industrial internet of things, O small because it is of off, and is a cyber physical system which is taking the complete advantage of networking, and which is also referred to as smart manufacturing. This is the evolutionary change that has taken place. Some pictures, yeah, the small PLC based control system, right? What you can see is the PLC, then modules, then there are some Another modules, then analog input where we can change the voltage current. We have got these fuses, then a wiring, then there are some inputs and outputs. These are analog inputs, discrete input, discrete output, switches, everything, relays. A control room with control panels. This is a typical control panel in which we can see an HMI, right? It's a hybrid DCS, which is in between DCS and PLC, or we can call it as a PAC. This is VFD, which is a very important trend nowadays, variable frequency drives. No motor can be imagined without a drive nowadays. This is a panel, how close the wiring can be, you know, and this is a SCADA screen, which gives you the realistic view of the process that is running behind. This could be little complex. We did it for Bangalore Chemicals, and the last one could be the slide you were waiting for, right? I think this is the beginning. We can continue our interaction. I'm sorry that we could not have the real-time interaction here, but I would like to finish my presentation with this, and I hand over to the organizers. Thank you very much. Thank you for patient listening. Just a minute. I think I have got some questions. I will try to answer few of them. Yeah. So I have got some questions from the Trupti ma'am. This is Karthik Harris. Let me come to the screen. Sir, is there any difference between automation and autonomous systems? Yes, fantastic question. Automation, in true sense, the definition which I give you of automation, right? Any mechanism that takes place on its own without human intervention, right? A car is there which moves on its own, but there is no driver, which is the human being. Then that thing will be called as autonomous, which is the next step of automation, right? And that is in true sense the automation executed, right? These autonomous systems are coming in now. So for example, in this particular challenging situation, what we actually look forward to is, like for example, you might have seen those news on the TV that train is being sanitized. So there, what are they using? They are using a robo for this is autonomous system, right? Moving something on its own. So good question. I hope I have answered that. And Shashikant Sutar is asking, what is the use of automation in AI? AI is artificial intelligence, I suppose. Use of automation in AI, or I would put it in reverse way. How can I use AI in automation? Automation has been there, and I want to look forward to some new avenues of automation. How I can execute those things, that is very much possible through artificial intelligence. Artificial intelligence is going to be very, very important tool for giving a new generation automation systems, right? So these are the two questions. Then what is the function of engineering station? One question. Engineering station and operator station, this is just the, what you can say, division of a function within the control room. There are some engineers, there are some supervisors, there are some operators, and earlier there would be separate engineering station and operator station. If you look at the DCS system that came for the first time from Tata Honeywell that time, right? They had given an engineering station and operator station separate, and later on the same company came out with a new version, and they called it as a universal station, right? In that, what they did, station means it's a machine, it's a PC, right? So what kind of operations you can do from that particular machine, if he's the operator is working on that particular machine, then that becomes an operator station. And this kind of security is just possible through passwords and all other stuff that is available in PLC and SCADA systems. So just like an engineering station, there could be some other stations also. Vipul Gohil, currently which PLC is used in the industry? He is asking. Perhaps he is asking me the brand. I can't answer this question with that, but it all depends on application that you have to choose the given PLC. So-called, Rockwell Automation, Honeywell, Schneider, these are the big brands, international brands. But forget about this. There are more than 1 dozen PLCs available in the market now. You have to be really smart to choose these PLCs for the given application. Don't go by the brand. Don't go by the trend, please. Then another question is, I want to pursue a career in automation. What should I do? If you are in instrumentation, you have already started. You don't have to do anything else now, right? Just pay attention to what you are doing, stick to some fundamentals, and be with some right people for guidance. Vipul Gohil, in IoT, what is use of automation, as well as in machine learning, which automation systems used? Okay. Now these are the new technologies which are being employed in executing automation systems. IoT, like I told, because IoT is gathering the data. It is about sensors. It is about softwares. Because if I give you an example, there is something called, as in industry they talk about the asset management softwares these days. What are they? Do asset management softwares need more sensors? Yes, perhaps. Because once the data gathering has taken place, now we have to really play with the data, right? A big data, huge data, analytics, data analytics. These things are becoming popular simply because people are wanting, they want ready-made solutions. I want my plant to be protected by the automation system itself, or there is something called an expert system. So these are going to be new tools which will take the automation forward, right? And you don't have to worry about this. This technology is coming in, and definitely this will help. That is, IoT is the latest trend that is going on so far as manufacturing industry is concerned, smart manufacturing. And just like I told you, so students should understand what is 4.0, not 4.0. It's a 0, 0 is 0, because in computers 0 and O are always confusing. Okay, so uh, uh, sir, what is the difference between learning and IoT, which has more importance at industrial level? Okay, machine learning, deep learning, artificial intelligence, these are all extensions, robotics, right? These are all going to aid the automation system to move forward, let me tell you. And you as an instrumentation person, as an automation person, you have to be very, very flexible, just like flexibility. When it comes to flexibility, what comes to my mind is ISA. Let me talk about this. ISA. ISA is what? When it began, this process began in 1945. What was its name? Instrument Society of America. They changed its significance. They are Instrument Society of America, right? One good joke I remember. When ISA president came to India and he was sharing with us when he went to some social functions in USA, and he introduced himself as the president of ISA. Then the lady asked, "What is ISA? Instrument Society of America." Then she asked a very interestingly asked a question out of curiosity: "What instrument you play?" Right? Instrument means she might have thought that he must be playing guitar, violin, and all that. These are the instruments. These are the conventional meaning of the society. But later on, they changed this meaning of ISA, keeping those ISA words same, to Instrumentation, Systems, and Automation Society. ISA remains same, but its significance and its purpose, its meaning, perspective changed, right? Then they came out with a new name, that is International Society for Measurement and Control. This was the name for some many years in between. Then they changed now over to International Society of Automation, ISA. I remember when many students used to ask Mr. Godbole, who retired as the chief engineer from Hadilia Chemicals. So we have the ISA student section, and we are not getting any benefit. Nobody is doing for anything, and all that. It's of no use. Then Godbole said that ISA is useless. What do you mean by ISA? ISA are just three letters. Unless you become a magician, those three letters will not come pop out as a magic. These are magic letters, but you have to become a magician for that. You have to use them, right? So just like that, be flexible and try to be open to new technologies. Okay, so there are some many more questions are coming. Uh, how this is from Professor Godse. How freshers can develop various skills to start their career in automation? Yes, sir. Good question. Because after education, what they should think of is skills development, and which is possible through training, like I mentioned. So they should start off with new technologies like PLC, SCADA, DCS, small things. But they must understand one thing, and through the understanding of one, they should enter the second. So they should not just simply going on completing different certificate courses. And I have got so many courses, and that will help. I don't think that will work. Okay. Uh, I don't think instrument engineers should learn machine learning and all this stuff. So I don't think so. But you should be aware about that. Yes, I will definitely say that. Right? You should be aware about this. And there are some questions. I think the time is really challenging, and I have tried my level best to answer most of the questions because the time challenging because you all must be waiting for your food, and I don't want to really come into that. Uh, so I think I will request organizers, and it's my request that see, please, I know you all have got many questions. Why don't you ask these questions on my mail bitc2104@gmail.com, because let this be a trigger of point, it's just a beginning, and let this be converted into a process. Let us be in touch. I'm glad that the Vidyavardhini College gave me this opportunity to interact with a lot of international people all over Maharashtra and perhaps over the country. And I'm really thankful to them. And I suppose I'm waiting for the signal from the organizers what to do next. Yes, madam, because we are running really out of time, and we need to stop the session. Thank you very much again. Thanks a lot. Let's be in touch.
Thank you, sir, for sharing your precious time with us. I deeply appreciate the wonderful presentation you delivered in the webinar. Today, Mr. Omprakash Barure, Principal Automation Trainer of BAGESHREE Instrumentation Trainer and Consultant Mumbai, enlightened us in the area of evolution of automation and technology. He started with the story of automation, then explained fundamentals of automation. He nicely explained why automation is needed. Then he described what is to be automated, then clarified the benefits of automation. He explained various tools used for automation and thus described the evolution of industry. I also thankful to all participants for their active participation in second day of webinar series Tech Talk 2020 organized by Department of Instrumentation Engineering, Vidyavardhini's College of Engineering and Technology, Vasai. Thank you.